Okay, here we're going to look at solving exponential equations with logarithms. Here's an example. It says world population in billions during the year x can be modeled by this equation here. Solve the equation for when the world population is supposed to be estimated to be 5 billion. Now p of x is in billions and then x is in the number of years. Okay. So what they're saying is when if p of x, when is that 5 billion? Okay, so here's our equation. We need to find the year that makes this statement true. Well, we need to get the exponential by itself. So remember, the exponential is its base and the exponent. So this 3 here, we need to divide this 3 out. Okay, so that gives me 1.017 raised to the x minus 1960 power and equal to 5/3. Okay, that's step one. Always get the exponential by itself. Then once you have the exponential by itself, you're going to do what we did before with that change of base kind of idea, log both sides with something that you know, base 10, right? Log base 10 of 1.017 x to the minus 1960 equals log base 10 of 5/3. Okay. Then power rule, we're trying to get at that exponent. That's the reason why we're doing this log of both sides. It allows us to get at the exponent. Now the exponent needs to come down as a quantity. So watch, x minus 1960 like this, because then that's times, right? That whole thing is times the log of 1.017. If you left out the parentheses, it would just be x minus and only the 1960 times this, but it has to be the quantity times that, equals log 5/3. Alright, now we're still trying to solve for x, so it's important that we had quantity times log because we want to get this alone. So either distribute, but I'm just going to divide the log out right away, okay? So like this, take and divide both sides by the log of 1.017, right? Now see, that's this again, log of 1.017. Alright, they cancel there. So now I'm left with x minus 1960, I don't need the parentheses, equals the log of 5/3, right, divided by the log of 1.017. Now what do I need to do to both sides to finally solve it for x? Yep, add the 1960, right? So add 1960, add 1960. So my answer finally, let's move down a little bit, is x equals the log 5/3 over the log of 1.1017 plus 1960. Now that's the exact answer, but we need to find out in years what it would be. So I've got to put it in the calculator. I've got to be careful how I put it in the calculator, but I need to put it in the calculator. So let's grab the calculator. Alright, so I am going to put the numerator in and divide it by the denominator and then evaluate that, add 1960. So we have the log, base 10 of 5/3, okay, there's the first part, divided by the log of 1.017. Alright, and then I could just add 1960, but I'm going to hit enter first and then add 1960. Alright, so 1990. So, let's go back here, and it said, solve the equation for when the world population is estimated to be 5 billion, and x is the year, so that would be 1990, would be the year then, right? So we say approximately 1990 the world population was 5 billion. Okay? Alright, let's move on to another problem. Alright, here are two more exponentials. So, to solve them, kind of do the same thing. You need to get the exponential by itself. So that's this portion first, before I do anything. So, meaning, okay, undo it. Let's add the 4 to both sides, right? That becomes 3 times 2.1 to the x equals 30. Okay, go ahead and still get the exponential completely by itself. Divide by 3, because that says 3 times 2.1 to the x equals 10. Okay, Now I'm ready to go and take the log of both sides, right? I'm ready to actually get this x down out front so I can solve for it. But you have to take the log first before you can bring it. So log base 10, I choose, right, of the 2.1 to the x equals the log base 10 of 10. Okay, what's nice about this is that over here, it's log base 10 of 10, right? 10 raised to what power is 10? 1. And then this comes down out front, so we have x times the log of 2.1, right? Base 10. So, one step to get solved for x, divide both sides by log base 10 of 2.1, log 2.1. So these cancel. We have x equals 1 divided by log of 2.1. That's the exact answer. Now to get the approximate answer, that what this is, it says 3 times 2.1 to some power minus 4 will equal 26. Well, what power do you raise 2.1 to? Well, right here. Calculator. 1 divided by log of 2.1. That number is 3.10, right? Well, let's go 3.103. So 3.103. 3.103. That's the approximate. All right? Let's see that in action. 3.103. If I take up my calculator again and go back here, so right here, 2.1 to this power. So watch how I'll do this. I'll do 2.1 to the second answer. That's this guy, right? Okay. Look at that's 10 because that holds that whole thing in there. If I did an approximation of 3.1, watch this. 2.1 to the 3.1. This isn't going to be quite 10, is it? Okay, so that's why when I go to and check the answer, I try to keep the information the computer gave me. So this whole thing gave me 10. And then it says 3 times 10 minus 4. Yep, 3 times 30, or so 3 times 10 is 30, minus 4 is 26. So that worked, right? If I'm using the approximation, though, I'm not going to quite get my 26 with this, right? Because now if I multiply it by 3 and then subtract 4, I get pretty close to 26, but not exactly. That's why the approximation is a little off. Okay, just an approximation. All right, let's erase this little mark, and let's try the next one. Now here, this is different because notice that there are exponents in both of them, here, and they both have an x. They both have an unknown. So I can't isolate it. Okay, it's already kind of isolated, right? Those x's are. Alright, so basically what I do is I need to log both sides so I can get those exponents down. And since we have e, I'm going to choose natural log. Let's do it this way. And I'll natural log that and natural log this side. Then I can take this down as a quantity again and take this down in front of here. So that would be x minus 1 in parentheses coming down times the natural log of 5. And this would be the natural log, it would be x times the natural log of e, right? It'd be x times the natural log of e. But the natural log of e, that's 1, right? So that took care of that. Alright, then over here, look at I have x and x. Well, in order to get, I need to solve for x, so I can't have x in terms of x. I got to get them together. So what I need to do is distribute this natural log of 5. So I need to take the whole thing and distribute it here and here. Okay? So it's x times the natural log of 5. And then minus the natural log of 5 equals x. And I've got to get my x's on the same side. So that term has an x and that term has an x. They need to be on the same side so I can factor that x out. Alright, so let's go ahead and subtract x times natural log of 5 from both sides like this. Okay, you got to subtract the whole term, right? Alright, this on the left side would be the natural minus the natural log of 5, that's that guy, equals x minus x times the natural log of 5. Now, the term with the x's here and here, it can be factored out. Right? Take it and factor it out, just like any kind of factoring. Natural log 5, the negative there, and then take the x out, that becomes 1 minus natural log 5. See how the x came out? If I distribute it back in, it'd be right back up to this statement. Now, I'm solving for x, so guess what? Divide by this whole big mess. 1 minus natural log of 5, 1 minus natural log of 5, right? They cancel here, and then this is the answer. So x equals negative natural log of 5 over 1 minus the natural log of 5. Exact answer. Now we got to get an approximate, right? Because I want to know, well, 5 raised to what power and e to raise to what power. Grab the calculator here. Alright, so I'm going to be careful putting this in, but we put a negative, the natural log of 5, divided by the whole denominator now. So the whole denominator, I should actually have parentheses around that when I put it in, because you got to, if you just divide by 1, it'll be like this. That means just dividing by 1. So I need to go back and I need to put parentheses and divide by 1 minus the natural log of 5 like this. And then an extra parentheses. So there it says the same thing that I have written. And then I can hit enter and 2.64. 2.64. So if we put 2.64 in for this x and this x, both sides of those equations will be equal. Maybe you should try that. Put in 2.64 here and 2.64 there. Actually, I have one for you to try now. So see if you can find the x that satisfies this statement. So solve it using the same thing. Remember, isolate the exponent. Okay, now I'm going to quickly do it here. I would first add 6 to both sides. 4 times 2 to the x plus 1 equals 44. Then I'd go ahead and divide by this 4 over here, and that to give me 2 to the x plus 1 equals 11. Now remember, I'm trying to get it solved for x up there, right? So I need to log both sides. So I'd log base 10 this side, x plus 1, log base 10 of this side, bring down this out front as a quantity. Remember, if there's more than one number, it must come down as a quantity because it's times that. Alright, I'm trying to solve for x, so I'm going to actually undo this multiplication by division here. So divide by log 2, divide by log 2. These cancel. So I'm left with up here of x plus 1 on the left, log 11 over log 2 on the right. And my last step basically would be to get rid of this 1, right? Minus 1. So x equals log 11 divided by log 2 and then subtract 1. That is the exact answer. Now let's put it in the calculator and see what we got. Log 11, and my parenthesis, make sure to do that, divided by log 2. Now to be safe, I didn't put these in parentheses. I should evaluate that first and then subtract 1 on the end like that, just to make sure. 2.45, so 2.46, right? 2.46. If I go ahead and put that back in there, it should come out to be 38. You can check it yourself.